Hello, everyone, and welcome to the Geek Nerder podcast. I'm your host, Kaivalya Apte, and I'm joined today by Arslan Ahmad, who is the author of the Grokking series, the popular one on system design and coding interviews. And he has worked for companies like Microsoft and Meta, and he has a vast experience designing, distributed systems and complicated mission critical applications. So I'm really excited to have you, Arsalan. And let's start with a little bit of introduction about your background, how you ended up being a software engineer, and what you're currently doing, and what's your mission.
Right. Yeah. Thanks. Thanks for inviting me. I'm happy to be here. Um, so my background starts with one course actually. I was trying to interview at Facebook at that time, 7 8 years ago,
Yeah.
and I actually failed that interview, the system design interview. So I wrote a course once. In my second try, I succeeded. So I wrote this course called Grokking the System Design Interview, and it starts selling from that point onward. Um, 3 4 years ago, I actually set it up a proper company around it. It's called designgurus.org, and I started writing other courses. So, so mostly system design was my interesting was the subject of my interest. So I wrote a Grokking the System Design and Grokking the Advanced System Design, but then I also moved into the coding part as well. So grokking the coding interview and grokking object-oriented design interview, those are specifically the approaches I try to follow in my interviews, and I put them in the course and started selling. So right now, I'm I'm running a small startup, you can say. We are building. We have already a platform working. It's a learning management system where we have these courses for software developers to help them prepare for their coding interviews and system design interviews. We have 5 courses, so we are working on adding more courses and building this platform, which would be text and video based, and it would be interactive to help developers actually learn system design, not for interviews, but actually for their careers as well.
Awesome. Yeah, that's very interesting. So, I mean, I like system design topics very much because it's so vast. I mean, there is no single answer. There's always trade offs that you make.
Right.
There's always context to it, depending on the business, depending on the domain. So I love that topic, and yes, we are going to talk about that topic only, system design, because Arsalan has the expertise in system design. I have very much interest and some experience there. So we are going to make it very focused on system design. Arsalan has a master template that he thinks makes a lot of sense for like thinking at a high level when you approach any system design problem. So we are going to discuss what that master template looks like, how it can be applied to interviews and your real job, and then we are going to take an example of a system like Instagram, and we'll try to design a system like that, high level components, and see what parts of the master template make sense there and why. So that's the overview, high level idea. But of course, we are going to make it a little informal, like two engineers are brainstorming on a whiteboard session, such that it's more relevant to you guys. So yeah, stay tuned and watch the full episode. uh, let's start with the master template itself, right? What does it look like?
Yeah, yeah. So I should share it right away, right?
Yeah.
All right. So the idea of the master template was we have so many system design problems, and it's the challenge is how would I get organized? There are a lot of components that can be discussed, and one of the biggest challenge I felt was I was not able to touch upon certain stuff, or some things are simply they did not come to my mind. So I just wanted to have a list of things that that I mention them in the interview, and if the interview really likes him, then we can go deeper over there, right?
Yeah.
These systems, scalable systems, they need years to develop, but in an interview setting, the idea is you need to tell your knowledge about distributed systems in general, and dig deeper wherever the interviewer feels like you should go, because as an interviewer, our target is to take the interviewee into a uncomfortable area where they need to think, they need to design, and then we evaluate stuff.
Yeah.
So this template that I'm calling a master template is trying to mention all those 7 8 big parts that can be part of the most of the systems that we design, especially in an interview, right? In practically they there to we have all the big systems, they need these components uh, in some way or the other. Okay.
Yeah.
uh, so over here, we can say, let me go through this template and big parts of it quickly, and
Yeah.
then we'll dig deeper with a practical example, as you mentioned,
Yeah.
Instagram.
Hmm.
So I've tried to draw on it. Actually, if I try to show you how big this is, so that everyone has an idea.
Hmm.
I don't know. It will be small, bigger. It will be little smaller, but we'll dig deeper. So I just wanted to show you this is the whole thing that we're gonna discuss. It's not very big, we're not very intimidating,
Yeah.
but we'll try to see. Uh, okay. Is the font look okay? Yeah.
Yeah. I think
Okay.
it's fine.
So generally, let's start with the client. So client is the main user. You can say it's representing user in our system. We always have a load balancer and the gateways, API gateways in this case, to distribute traffic and uh, process our authorizations and authentication kind of system. We'll discuss this part later, but generally all distributed systems have these kind of components. Um, then in most of the systems, we wanted to segregate the data and the control flow, right? Data represents the pictures or the videos mostly, and the control flow is the content. For example, in Instagram's case, the text that you write, or the related things, for example, comments or likes or dislikes, all those control operations. It's easy to segregate these two operations,
Hmm.
and one of the biggest advantages, then later we can scale these operations independently.
Hmm.
If we feel like that the data is taking too much time, people are uploading bigger videos, or the system is now allowing bigger videos, then we can scale the data part independently. Uh, if we see the data part, uh, it generally involves taking the video and data and storing it into a file storage system, a distributed file storage system, and then asynchronously processing that video and photo to generate either the thumbnails to it, or encode it into different formats so that it will be accessible everywhere. So
Hmm.
that can be done in a asynchronous way, and it should not be a block operation for user. And we'll let user later know that, oh, your video has been processed and it been available to other users. The control operations, generally linked they're linked with the metadata operations that you have around your objects involved in your system. In this case, a post, a picture, a person, uh, you know uh, and then that data goes into a database, a SQL, NoSQL database. There's a cache involved always. Either the cache is responsible to write the data and fetch the data, or you can actually write through or write back strategies for the cache. Uh, so this is one component. Feed generation is another component. So whenever a control operation happens, if you like a post, you delete a post, you share a post, or you add a comment, all those meta operations, they are pushed to a queue, which can process all that data and in a smart way generate a news feed for you, put it in the database back, and then it's shown to you.
Hmm.
This is a common feature. It's been used everywhere. All the social media, from YouTube to, they have news feed, a homepage kind of thing, where based on your likes and priorities, everyone needs some intelligent system over there.
Yeah.
Searching is another important part. You can search based on a keyword or a hashtag. We need to have data indexed in such a way that we can efficiently, quickly search our data. Notification is another part. If I follow certain people and I have enabled the notification, I need to have a mechanism that
Hmm.
can notify me whenever they post or stuff like that.
Yeah.
Partitioning and replication we can discuss whenever there are distributed systems. Scalability and availability issues are always need to be discussed, especially if you are a backend engineer. Around that, there's a big chunk of discussion can happen over there. Then you have the warehousing part, where you take the data and process them offline. Either you generate reports to it, or you generate this data that is fed into external systems or some machine learning systems that generate some metrics and push it back into the system, and they flow back and then get reflected either in newsfeed generation or the way the system works.
Mm-hmm.
Uh, yeah, so there are some other external components that we can discuss, but in general, in short, these are the bigger components that can be dig deeper during a discussion. The data, the control, the news feed, the notification, and the search part, they're nearly everywhere. They're there. All of these systems in itself, they're a system design problem. Like you won't be. I mean, people can ask you in design and Instagram, but eventually they'll arrive at some certain part of it where you can actually go deeper and see, okay, how the things work, and then you can actually change stuff over there. So I guess, yeah, this is a high level introduction of the system. We can take an example and then actually go deeper in discussing all these components one by one.
Yeah, yeah. I think that's a great high level overview of any system, and I see a lot of patterns here. Right, these are okay. These are components, but there is always a reasoning behind why do you want to have a load balancer, and it's a pattern. Why do you want to have like a separate block server and a metadata server? Why it makes sense to separate them out? Why do you
Right.
need a CDN? Why do you need a cache? So the idea is to not just remember that, oh, that there are multiple servers, so let's put a load balancer. But the idea is to remember the patterns,
Right.
which over the years people have developed based on real world experiences. And then, as you correctly mentioned, so in the interviews, you can talk, start talking about general high level, but then there is one area that the interviewer would want to go deep. So
Right.
having deeper understanding of all these components will
Right.
definitely help you. Otherwise, it's not going to help. So this is just to get started, but does not skip you you know help you skip the deeper understanding of any component. So that's like a little disclaimer.
Mhm.
But let's start with the Instagram example, because that's where things will get interesting, and we can go deeper. So let's take two use cases that a typical Instagram like application has.
Right.
The first one, of course, as a user, let's assume you're all registered, you're logged in, but you want to post photos and videos primarily, along with some metadata, which is captions and some hashtags or location, whatnot.
Right.
Uh, and then the second one is, once you have uploaded the photos and videos, you want also to get a news feed depending on uh, your connections or followers who have uploaded something, and you want to look at the news feed in a proper manner. So
Right.
let's take these two use cases. Maybe let's start with posting a photo and a video, for example.
Right. Right. Yeah. Yeah. So, I mean, you aptly mentioned actually, these are all patterns. The CDN is the static content and why it's efficient to actually cache over there, and then uh, segregating your control and data flow, even your sharding mechanism, your searching module, the index. It can all develop in a very complex system on their own.
Hmm.
So that's why. So the patterns are there. They are the recurrent problem, and then we have the solutions,
Hmm.
which has been tried and tested.
Yeah.
So yeah, actually that would be an interesting way to redraw this diagram and actually referring to the design pattern
Hmm.
which we are trying. It's a
Yeah.
good idea. I'll actually focus on that.
Yeah.
Um, so yeah, so let's take the example of Instagram. So Instagram is a very good, very famous, interesting example, and it actually covers a lot of other systems too.
Yeah.
Instagram is quite similar to, it's a social network. So Facebook is there, or Twitter, or LinkedIn, or
Hmm.
Instagram itself, or even Quora. Quora has a
Yeah.
question answer. Okay, there it's like a post,
Yeah.
and you need a news feed. Stack Overflow, or LinkedIn, anything. So all these have the similar problem,
Mm-hmm.
same data models. They have to store data and then okay rank it and show it to users and okay search and stuff like that.
Mm-hmm.
Uh, so so yeah, let's start with very simple test cases, use cases. One is okay, the user uploads a post and then they need to generate a news feed. The system needs to generate a news feed to show them the relevant and appropriate posts that they like.
Yeah.
Over here, uh, the load balancer at API gateway uh, is the early part, is the beginning part of the system, right? Most of the software engineers, they don't have experience actually working with these. They're either a front end engineers where they are working with the web servers and around that the back end engineer or a full stack engineer. But these people, they're generally a DevOps, more kind of an operation, or configuring and manipulating these components. This is quite heavy. They take heavy load. But most of the time, I have seen software engineers, they don't have very much deep understanding of these components.
Yeah.
So I guess, I mean, either you have to read about them or at least mention them. Okay, I never worked on the load balancers, but I know, okay, these are the bigger functions of these components, and that's
Yeah.
how. API gateway is definitely a good thing to study about, because it can not only route, it can load balance, it can route intelligently, it can cache data, for example, because it takes request and pass it to appropriate server, right? So
Mm-hmm.
it can cache the similar request so that it can return the results right away. Uh, the transformation, sometime you need to take the request, transform it to send it to this appropriate server, or it could be an API server or a Lambda function, the serverless functions, and then get the response back, transform it back to send it to client. Similarly, rate limiting we can do, uh, and or reverse proxy, which is hiding the server side from
Mm-hmm.
the clients. So it takes all the knowledge of the backend and route the request appropriately. Similarly, logging, monitoring, we can do a lot of stuff over there. We have this is our first entry to the system,
Mm.
kind of.
Yeah.
So it has good metrics number, and we have a gateway kind of thing where we can manage stuff. Load balancer before it is generally used to you know to fail safe. Load balancers have generally smaller function, so they're just simply load balancing the traffic among the API gateway servers that
Mm-hmm.
could be in different regions, and specializing either in the malicious activities, the DDoS attack and stuff like that. API gateway can do that too, but you want only load balancer to be very simple and do all these bigger kind of aspects, bigger kind of features, and then uh, uh, give the control to the API gateway, which intelligently route your traffic. So in
Yeah.
this case, for example, excuse me, when a user add a post, we as we said, we can make that upload part of a post into two steps. One is the data and the other is the control flow. Let's say data is always a simple thing. You can say, like in Instagram case, I think they allow only smaller videos. They don't allow. But in YouTube's case, for example, the bigger videos could be there, multiple hours of video. So uploading it over there to your distributed file storage system,
Mm-hmm.
and then pushing a task to a queue, post processing queue, asynchronously processing that video. Sometimes you have to generate thumbnails of the photo, of the or the video, you can say, and then also encode it or change it into different formats so that users all over the world using different devices, they can use it. Um, you can say we have a video processing service over here, which could be a distributed processing uh, component, which has so many workers. If the queue size is increasing, it can spawn new workers based on the load, so independently it can work. um, the storage itself could be a local file storage, For Instagram, definitely it's all Facebook storage. But if you are a small service, you can actually use S3 or other independent cloud services. You can put the data over there. So
Yeah.
the right part is over here. This whole actually represents the right workflow. Um, then, since this is a static data, it won't change. We can actually push it to a CDN. So CDN actually is responsible for, at a high level, caching the static data.
Hmm.
It could be a web data or your post or your video. It can be put over there, and the clients directly get data from the CDN. CDN is, you can say, a bigger cache, but it has other benefits too. It
Mm.
increases your availability, because now the data is at multiple places. You decrease the load on your data servers that are supposed to serve the write traffic or read traffic. So a lot of data in CD in in Instagram's case, most of the data is static. The video or photo data, it never changes.
Hmm.
Imagine even a celebrity, they did a post, so that data is going to go everywhere in the world. So it's very good to put it in the CDN, and then the CDN manages itself, that which is the closest edge server, or the server which holds the data,
Yeah.
and then redirect the traffic over there. So write and read part of the data generally involves all these components. Yeah, there can be more discussion around storing a big file in a distributed way, but that could be
Hmm.
another full-fledged system design problem.
Yeah.
That, okay, we have a big video, and how I'm going to store it, make different parts of it, what is the efficient way, so that, but that involves another system design discussion.
Yeah.
Other than that, if you have any question, yeah, we can go over here, otherwise.
Yeah. Absolutely. I mean, at a higher level, it does make sense. So basically, uh, breaking it down, right? So let's say I'm a user, I'm posting a photo or a video along with some metadata. So I make a post, it goes to a load balancer, or basically a router, because you want to route it to a appropriate API gateway. And API gateway is a slightly more sophisticated component, because it has other abilities as well. So it can
Yeah.
route to a specific server on your backend system. And
Hmm.
then, as we mentioned, so this is basically like a very simple pattern. So you have multiple servers, you want to evenly distribute the load, so that's why you want to have a load balancer. And then you have multiple components behind the scenes. So API gateway is basically used to hide the complexity, hide the details that the user doesn't, or the client doesn't have to know about. uh,
Right.
Now, I want to talk a little bit more on the segregation of the two flows, right? So there is
Hmm.
static content, which is the images and the videos, and then there is the metadata. Let's say the caption or the hashtag, or when the post was generated. Let's say a timestamp. So,
Right.
is it happening in parallel? So, what is the typical scenario? Let's say in case of Instagram, I mean, of course, it can also happen sequentially. So,
Hmm.
I make a write for the metadata, and then I go to the block server to upload the images and video chunks, or I do it in parallel.
Yeah.
So,
So
what? Yeah,
yeah, so it can be done parallel, right? But the notification to the client or the user is done when both the steps are done.
yeah,
In YouTube's case, for example, when you're uploading a bigger video, you can actually leave the page, and they say, "Oh, we'll notify you when the video is ready."
yeah.
In Instagram's case, we can assume it's a smaller video, so processing takes like few seconds, based on your queue and your
Mm,
SLAs. So it can be blocking, so your data is already there. You use the metadata servers to upload your data about the post and stuff, and it goes all the in the databases, and the video is over there stored in the system, and you notify that, oh, your post um, is successfully saved or
hmm.
received by the server
Yeah.
side. But then the news feed generation part can happen. It can take like 1 2 minutes based on
Mm,
whatever kind of agreements you have.
Yeah.
Because as soon as the post is finished, the metadata server now responsible to push an event to the feed generation system that,
Hmm.
okay, that's a new item come, and now please do your necessary work to figure out where does this post uh, go and what users should see it in their news feeds. So
Yeah.
all that responsibility will be there for the feed generation system. Over here, what we have discussed, that the control flow, the data that the user uploads about the post, all the hashtags or the little bit of description if they have it, or the title and everything, it goes. Let's say in this case, I said it's in a cache, and the cache is responsible to putting it into a storage system. At a high level, this is what happens. But then the first discussion is the type of database that we use. Like, okay,
Mm.
we have NoSQL database, SQL, and or even mix as well. Some monitoring stuff could go in a different kind of database. But if you have a you know Instagram kind of model where you have a relational uh, entities in your system, then you might go with the relation database. Um, I'm not sure what does Instagram use, but Facebook actually uses MySQL. Although I mean it's an old system, but they were able to scale it efficiently.
Yeah.
Yeah. So right now, I think this discussion between MySQL and SQL is getting grayed out as well, because the NoSQL databases, they're trying to give feature of the SQL databases.
Yeah.
uh, and the SQL, for example, Postgres is now giving you option to actually store documents. So the
Mm.
NoSQL kind of thing, although the NoSQL databases, they still say that their availability and eventual consistency is their model, because that's what they've been used mostly, and SQL is mostly solid, the acid base required, and then they say we go with high consistency but lower availability kind of in capture stuff.
Yeah.
So the systems over there. So it's always a discussion during an interview, what kind of system we can use. In this case, we can actually go with the SQL Server, because we have relationships between entities. We have a post has a user, um, and then a post could have a comment. The comment. So this is all relationship. A person follows another person. So that is also a link.
Hmm.
This can all be stored in NoSQL. The way even now NoSQL, they are giving you secondary indexes, so you can actually quickly search and find.
Yeah.
So there's no, like, I guess, clear, straightforward discussion. Oh, this is directly can go into that. The most optimized, probably, database could be a social graph. Actually, it's a graph database.
Hmm.
No one, no, I don't know if any of the bigger social networks, they use graph databases. Facebook manages all of their social graph in MySQL, actually. So, but graph databases, they are relatively new thing. So you can actually use this whole thing as a graph.
Yeah.
Because it's easy to understand and figure out the design of the system using a graph.
Hmm.
So when we dig deeper, I'll try to bring this discussion back.
Yeah.
Yeah,
Absolutely. So that is like SQL versus NoSQL is a huge topic, and of
yeah,
course, we can talk a little bit more about that. Uh, I just want to, summarize kind of what we have discussed so far.
yeah,
So we talked about the load balancer layer, and of course, this load balancer can be a global load balancer, like our cloud providers provide these days. There is like, the closest point of presence for any cloud provider. So these are edge locations, and then they route it to your server, which is, let's say, the API gateway, and then you reach the actual processing server, which is processing your data. And then we talked about separating out the control and the data flow. So control is mainly about the metadata. In this case, it's the hashtags, the caption, the user ID, and everything around that photo and video. So that we have. So don't think it's just Is it just static versus dynamic data though? So in this case, it's happening in this way. So photos and videos are static, so that we call block server. And then the dynamic data, I mean, typically it's not even dynamic because that is also static. Because once you make a post, I don't think you can edit that. Maybe on LinkedIn you can do that. I don't know. I'm not a heavy Instagram user, but maybe they don't allow you to change that. But the idea is to, store the metadata and the static data, which is photos and videos and documents on a different server. So
Right.
is that a good classification, or have you also seen some cases where it's not depending on the type of data?
Yeah, I mean, yeah, it could be one app server. Um, I don't know if, for example, we can have images in Stack Overflow,
Hmm.
or maybe so it's all text data and everything over there. So we don't
Yeah.
need so any kind of segregation. This is like a typical the command and query pattern.
Hmm.
Where you try to distribute the commands and the query, the read and write part, you can say.
Yeah.
Um, Most of, for example, storage systems. If I design, if I remember, Google file system. So over there, you're uploading files. So file
Hmm.
is the heavy data, but then you have the metadata of that file. How many parts of that file are there? So you
Yeah.
upload them separately in a database, in a storage system, you can say, and once the files are stored, then you actually commit. It's a two-step process.
Yeah.
Commit that over, this is how the file is laid out on the disk, on the final
Hmm.
disk, and then the commit happens, then it's visible to the system.
Yeah.
Yeah, biggest advantage over here is you can scale these two systems independently. um, and one of the biggest use is some servers are heavy on storage and some are heavy on cache or processing, right?
Yeah.
I mean, it depends what kind of, even the control operations can be divided into further two. One is heavy on processing, the other is heavy on cache,
Yes. Yeah.
on memory. so
Hmm.
so that so classically, when I was at Facebook, we were building a distributed file storage system. So the classical system, the previous system, was just one server, so they could not really scale. So
Yeah.
we need to buy like thousands of servers. So we need to decide, oh yeah, okay, we'll optimize this thing. So cost and all those things are always comes into play, and we need to figure out our exit
Hmm.
plan. Okay, that's where the bottleneck is. We're going to segregate these operations in different. So it's always good to, if you can, because in system design interview, generally the cost never comes up, but practically, cost is a big thing.
Number one
uh,
priority.
no one prayer, so yeah, it's like that. Yeah, did I answer your question?
Yeah, no, I think it makes sense, and that actually, I recollected a question which is very popular. I don't know if it's still popular these days, but the question is, can you store the image in your relational database? I mean, someone asked me this question. I said, yeah, why not? I mean, it's technically possible, but does it make sense? Depends on the use case. If you don't have those many images, if your images, let's say, are very small, probably you can do that. But the better pattern is to segregate that, because relational database is mainly for the transactional and the processing side of the data, and the image and videos and all that, they are heavy data, and they need storage, they need caching, and they don't change often. You cannot search based on that, and I mean, typically. So the idea was to separate that out, because both of these data sizes are different. And then if you end up storing on a relational database along with the images, operationally it becomes so difficult to take backups, because you have to take nightly builds and backups and whatnot. And along with the images, it's really, it's kind of skewed what type of distribution you have. So I think that also kind of is similar problem, that you have to think about what's the nature of the data and the type of the data and how it scales. So you have the ability to scale them separately, and I think that's kind of similar.
Right.
So yeah, I think that's a good idea to segregate that. uh, Yeah, so coming back to the flow, I think we are clear that why do we want to have a load balancer? Why does it make sense? Why do we have to? Why do we need a API gateway, for example? And then why it makes sense to separate out the flow of control data and the static data. Uh, then it goes to a queue, right? So it's all happening in an asynchronous manner. So
Mm,
if I talk about the control data, maybe it's not asynchronous, it's synchronous because you get the read after write property. But
right.
when it comes to the video processing,
Mm,
it is becoming asynchronous because you have a queue in between, right?
mm,
So how does this flow completes? Is it completely asynchronous that you're so the client is still waiting unless I completely save the metadata, but
mm.
the client gets notified in an asynchronous manner when the file or the image is uploaded. Is that the case?
Yeah. Um, so like the client needs to have a live connection when they are uploading something,
Yeah.
so that process will not finish until you have completely uploaded a file over there. But
Hmm.
you won't say that, oh, this is available to the users, but okay, as soon as I get the data, then I can notify, and the metadata plus these two operations are finished, then we can notify the client that, okay, the server, the backend has received your data. But then the video processing queue works separately, and the feed generation is altogether a different beast. As soon as the both things are okay, the data is received. Now we will take a little time to publish this data to the user. To the
Okay.
Instagram or Facebook. I guess over here, the biggest question probably is how the system actually figure out that a post will be shown to certain users. How do
Hmm.
they actually figure out that part where one user, which is following like thousands of users, let's say, and the data gets into their newsfeed, their home screen.
Yeah.
So that part, right now it's just one block feed generation service, but they can be like tens of services around it.
Hmm.
As we have seen the Twitter's news feed, the Elon Musk that man shared.
Yeah.
So it has very complex, ranking and filtering and authorizing parts that can go very deep. In a system design interview, I guess um, um, the discussion could be actually go anyway. I am not a security guy, so I mean I'm not. I think I'll never be discussing security part in a detail. But
Hmm.
okay, I can actually come up with the microservices, the components of this feed generation service that work together to generate a feed. And actually put it in the database so that the user can fetch that and show it to user.
Yeah.
We should we discuss that, right?
Yeah, yeah, yeah. We will definitely discuss that. I just want to, complete this flow first, so
Yeah.
we have the enough understanding of, all the like until CDN. So the post and kind of the read operation as well. Uh, so okay, so we store this in a file system and so okay, so this is another question I get asked. So there's a file system and there's like an object store. Like for
Yeah.
example, we talk about S3 or we talk about HDFS. I know some differences and some trade-offs that they make, some challenges that they face.
Right.
Typically, we end up just using S3, right? We just say because it's highly scalable, highly durable, and there's no scalability issues and all that. Is there a difference? Like, what is the key difference between a file system and an object store, for example?
Yeah. So that's very interesting. I mean, it should be read properly once at least, because this is one of the core concepts.
Hmm.
If you're really going to discuss storage in detail, over here I wrote the block server. So block and object, you can say the two big terms.
Yeah.
You can say an object is a complete, if I'm not messing it up, both of them, one of them. So object is a complete unit of storage.
Hmm.
For example, a photo
Yeah.
has everything in that object, so you can store it, retrieve it. It has everything in it. Block can be that, okay, this is a part of a bigger object, so
Mm.
one object can be divided into multiple parts. We store it in into maybe different servers,
Yeah.
different encoding schemes, and then there is a mechanism that is known to block server or the CDNs, how to construct this object from those blocks.
Mm.
Um, yeah. Um, so um, so there can be many actually discussion over there if we really go. In this case, let's say photos are actually tricky because photos are small objects.
Mm.
Video is a bigger object which needs different parts, but photo actually small object. It can be stored as an object. S3, you can say you can just store it as an object, retrieve it, and the CDN has the actual link to the photo. So when I say, oh, show this feed item to the user, it has only the link of the actual photo, which is accessed through CDN or the other servers. Similarly, even upload, even okay, I'm switching a little bit, but upload can happen directly to the storage server. You don't
Mm.
you a block server just say, okay, you are going to store an object to, or this is the ID, please use that and directly upload it to the server
Yeah.
instead of uploading to the block server, and then the block server is actually storing to a distributed file system.
Yeah. Yeah.
The distributed file system, you can say it's a file system just like the famous file systems, but we are managing everything, how we are dividing our files and storing them into different uh, you know uh, ways. So over here, the biggest concern about the storage system is the durability is one thing, and then it's how I mean, retrieval and storage is another thing, but durability is the most famous thing. That once I upload a stuff, it's quite, it should be ensured that I'll never lose that thing.
Yeah.
Imagine
Mm.
you have uploaded your photos to Facebook, and it should have it. They should never lose it.
Yeah.
So to increase the durability, or the even availability as well, they store multiple copies of it at a high
Mm.
level, you can
Yeah.
say. Same photo stored in two times, but now we don't use the classical way of storing a copy of an object.
Yeah.
Uh, so for erasure encoding and other smarter encodings are there. You make multiple parts of an object, and let's say I'm just saying high level, like six four encoding, which means every file can be divided into six parts, and you only need four parts to construct that object.
Yeah.
So those six parts will go into six servers. So the redundancy is already there, and the cost is nearly one half. When I have one file, I'm storing two copies, so I need 3x of storage.
Hmm.
One object, but taking 3x of the space. But with the erosion encoding 4.6 I mentioned, you actually ended up with six parts, four parts, and you actually make it to six parts, so it's the 1.5x. So more availability, more durability, but with lesser size consumption, you can say.
Yeah.
Similarly, it increases your availability too, because the data is available readily from multiple servers. Because when you're reading, you read it from all the six servers, and all the four servers that answered quickly, you actually were able to construct. Anyway,
Mm.
so that's a detailed discussion about the way storage works.
Yeah.
It's unless you are a storage person, they won't ask this much detail.
Yeah.
But if you are interested, you can always read the systems. In my Grokking the Advanced System Design, I have discussed Bigtable and Google File System.
Hmm.
Those are our actually distributed storage systems, and even
Yeah.
a little bit other stuff too. You can
Yeah.
actually.
Absolutely. And those are great white papers as well, right? Like really
Right.
deep and really interesting white papers. Uh, the another thing, and correct me if I'm wrong, is that on the file system, it's by its nature, it's hierarchical data. You have directories, you have subdirectories, you have files, and object storage is pretty much flat, and that's a reason. That's another reason why it's typically more scalable. You can just there's no
Mm.
relation, so you don't need to that overhead is not there. So
Right.
I just end up saying or using, let's say, Amazon S3, because why not? You have like 11 nines of durability and high availability. It's simple to use. It's highly supported. So, but yeah, that's another deep discussion we can maybe have sometime later. Cool. So another interesting point that you mentioned was, so instead of uploading this to the block server first and then the distributed system, is there a way to just like directly stream from the client to the file system, so such that the block server does not become a bottleneck? Because
Right.
if you are storing it there and then storing it in, let's say, S3, so S3, let's imagine it's like unlimited storage
Right.
possibility, but
Yeah.
on your block server you may not have that much. I don't know, on your server, I'm saying.
Right.
So is that also a pattern you have seen?
Yeah. So this is right now it happens. That's the way it should happen.
Yeah.
You don't upload it to two servers. So what
Hmm.
happens? The block server is responsible for creating the block, you can say, or the
Hmm.
metadata of the block,
Yeah.
or allocating a space in the cloud S3, let's say,
Yeah.
and then S3 will give you a link, and that link you forward it to client with some authentication or authorization part. So
Yeah.
that link would be available for certain time,
Hmm.
within minutes or seconds. The
Yeah.
client is responsible use that link to upload it directly, and then the block server get notified either from the CDN or either to the client that, oh,
Yeah.
this thing is done. And then you can say, okay, then, because this uploading to the two servers is not at all efficient
Yeah.
now. With the cloud storage, this pattern is everywhere. Everyone follows it like that.
Makes sense. That makes sense. Cool. So now we have our video in the video processing queue. There are workers and services who are processing and storing it in different formats. Let's say in the case of YouTube, maybe also Instagram, because depends on your device. And then it goes to a distributed file system. Uh, there is this component called CDN, right?
Mm,
And so there are two read paths, is what I imagine. Like one is very simple. So I upload a post and I instantly go to my profile and I check that, okay, it's there, right? So it's like read after write. And
mm,
then the other read part is it goes to like a feed service where someone else who follows me can see my post. So that is like two different read paths with separate guarantees.
mm,
So in one case I want it instantaneously. Like if I am told that your upload is done, I should be able to see it on my profile.
yeah.
And then the other part is someone else who follows me can
Mm,
see it, let's say, after 1 minute, 2 minutes, depending on their degree of connection and whatnot.
right.
How does is that separate or is this same thing?
Yeah, it should be separate actually, because this is the most frequent user scenario. For
Yeah.
example, I am watching your video, I add a comment, and then I'll refresh the page and see that the comment has arrived or not.
Yeah.
And there was a very interesting talk. It was an old talk, 5, 6, 7 years ago. YouTube had the same challenge.
Hmm.
Users, whenever they write comment, they refresh the page and comment is not there. Either they want to comment again or they say, oh, where did my comment go? So showing that comment right away
Yeah.
uh, was very difficult for the YouTube at that time. The way they think, it's always that, okay, the data has been received, but should we start serving, because there are sort lot of pending processes. So that workflow needs to be carved out properly.
Yeah.
So in the end, actually, in the end, YouTube ended up building a separate service that shows your comments only to you, but not
Hmm.
the other users, because they say it will go to the other users through an asynchronous process, because it goes through a ranking algorithm and everything,
Exactly.
but
Hmm.
since you want to see it, so they show it to you. So similar thing can be done over here. For example, in when you see your home screen, so one is your news feed and one is your home screen. Let's say, I
Yeah.
don't know
Home
what's the
screen.
fancy part. Yeah, home.
Yeah.
You open your home screen and you see your latest post.
Hmm.
So it can be shown to you, because that is just one post. You just go to the data of all your posts, which is reverse chronological order, and you fetch it from the database and show it. Metadata is already there,
Yeah.
object is already there too. If you are accessing it onto a server which is not able to show the video in that format that you have uploaded, maybe that part needs to be sort out. But yeah, it should be a separate workflow when you open your home screen, because now you're going to a different database table. Over there it's simple, a reverse
Mm.
chronological order, it never goes away.
Yeah.
In the news feed, actually, it switches.
Yeah.
It has more complex, more dynamic kind of data.
Absolutely.
So yeah, so this separation needs to be there, and it gets complex. Even the notifications, the small things that are triggered in your system, uh, and you really want a quick reflection on the page on your system. It always takes time and effort.
Mm.
I've not read completely, but the way YouTube has removed their dislike button was was one of the reasons. So there are these likes, and then there's just one counter for it, right? So there's no two separate counters and then managing. So they merged it. So things like all these notifications that needs to flow to the other users. It takes effort and a very complex system, because
Mm.
you really want a quick turnover of the things.
Yeah.
So yeah.
Yeah, that's a very interesting thing. I mean, there are two read paths now. Like one is through the news feed, one is like directly going to the profile. And
Mm,
by the way, I tested this on LinkedIn. I was just too quick. I posted something and I went back to my profile. I couldn't see it,
yeah.
and then I had to refresh it like a couple of times, and then I see it.
Then I
So
see.
it sometimes happen. I mean, it depends on your business use case, what kind of guarantees you want to provide. But yeah, that's a separate use case.
Mm,
Cool. Let's talk a little bit about the feed generation now, because
yeah.
So let's say, uh, just to set up a picture, right? So I am being followed, let's say, by thousands of people. I mean, realistically, I'm not, but let's assume that. And I post something and I want them to see my post as soon as possible in their feed. How does
Mm,
that work?
yeah. Yeah. So I have not done this thing. I'll just try to explain whatever comes into my mind,
Yeah.
and even you can actually, maybe you can even come up with your own design too, and it will be better.
Yeah.
Um, so imagine it as a graph. There are people who are following other people, or let's take an example. I follow you, okay, and you are a celebrity. I follow you, but you don't follow me, let's say,
Mm.
okay. And but I follow 100 other celebrities too. In my news feed there should be a ranking,
Mm.
that which celebrities post should be prioritized, or it's best suited for me. So
Yeah.
there's a system that is making that decision. So that is what all news feed generation ranking part is thing. So right now we are just discussing the ranking. How would I rank? The security and other stuff is a different, because once you rank stuff, generate stuff, then it pass on to other filters, and then eventually being shown. There could be some forbidden stuff too,
Yeah.
some graphic video or something. There's a lot of stuff that can happen, but as I understand, we're going to discuss the ranking part, how efficiently we can rank stuff. Uh, Practically, I would say there would be machine learning models that are either running offline, or they're crunching numbers and updating the ranking algorithm, or the all the parameters based on the rankings, or my behavior or the celebrity behavior. All that thing they crunch, and they end up generating something that tells me that what should be the ranking of certain stuff.
Mm.
Again, it's a lot of hand waving. But what could have happened? I mean, then, so there's this black box, a machine learning model that gives me a number that could be, we can call it an affinity number, let's say. So imagine a graph. social graph. It's me and it's you, and I'm following you, and we have a link between these two nodes. And since I'm following 100 other affinities, other 100 other celebrities, I have affinities for all of them. But
Mm.
let's say I have more affinity towards you because of my behavior. I read every post you have, I like it, share it, comment, stuff like, based on all that behavior and my
Yeah.
interaction with you, which is being fed to a system, and it generates this one number called affinity. Okay,
Mm.
it's again simpler terms. It can go more complex from there onward. But I have a link between these two objects in a
Mm.
graph which shows how much affinity I have. Now, once you create a post, right? So the algorithm needs to go to all the linked objects of this celebrity, and then it has the affinity of everybody. Based on that affinity, it generates an item, a feed item, which could be the a small metadata of the original post, that okay, this is what the priority, based on the different priority of different celebrities or different people that you follow, and generate this item and put it in the database.
Mm.
uh, this can take maybe, I mean, in LinkedIn's case, it takes like, I think, 2-3 minutes or something. It starts appearing in other people's news feed. So it could be another table which has, you can say, the reverse chronological or reverse ranking order, highest ranking plus recency added to it, and it has the feed items. So the viewing part is, so whenever the user wants to see their news feed, it goes into the database and fetch the, let's say, last 15 items and show it to me.
Mm.
And if I scroll down, then it fetches the next 15 items. So whenever a feed item or a post is being generated, the feed generation service, based on the affinity and relevance, or you can say recency scores, it generate a feed item for my newsfeed table and put it
Mm.
in that, and the view part just fetches that over there. It can actually you know swap some items too. For
Mm.
example, you posted yesterday, but today it got very much interaction. So
Mm.
so the post itself has a ranking algorithm too, right? So today, let's say they want to show it in my newsfeed. Yesterday, it was not showing, although I have a higher affinity, but the post was not very famous yesterday.
Yeah.
So it can actually go in the feed item table, remove that, or maybe swap it. There should be a mechanism there. It's a feed item linked to another post, and previously it was coming at the number 7, and now it should be number 2.
Mm.
So at a high level, you can say that is what the generation part look like. I don't know originally how they do it, how many components. I try to guess from the, for example, Twitter's case too, that they have a couple of two, three big components that try to rank stuff based on certain parameters coming from it. Um, Over here, I did not show the you know the ranking algorithm or the machine learning part, because, for example, every event that is being generated by our system, every like or every comment or anything, that goes into a database, and then
Mm.
a system gets all that thing and generate this signal, and that is fed to the graph. And the
Mm.
graph update, let's say, it gets updated into this affinity score, and based on that and couple of other parameters, it generates the item. uh, so that is generation. Viewing is also a different thing, because once you open, let's say, for example, you open your news feed, um, and you see your items, and you scroll them down and see fetch more items. um, but once, for example, you are at your home page and you are actually going through your item, you spend a few minutes over there, and new feed items come
Yeah.
into your feed, right? So at that point, the server still has connection to the client, and you get notified, oh, there are new items. So you have to either do the scroll down kind of feature or fetch it manually, because these items are not really pushed to the server, pushed to the client. So the discussion over here could be push or pull model. The client is always saying that, okay, should I get new item or not? Or the server is simply telling, oh, there are new items, please pull whenever you are ready. So
Hmm.
it's kind of a hybrid. The server is only telling that they're new items, they are not giving the data. But the pull operation, either through the swipe or the cursor or the through your mouse, then you go to the server, fetch new item, and your whole thing gets refreshed.
Yeah.
Yeah, read part is like that.
Yeah, yeah, yeah. That makes sense. I mean, I at a high level, I would kind of have a similar design where you have, like, let's say, a black box of machine learning models running, crunching data, all events, all interaction, engagements, whatever you call on different platforms. uh, I don't know anything about machine learning, so I'll keep that as a black box. And that
Right.
gives me a number, or let's say a classification of per post posted by someone, and depending on their interaction, it gives me a number that, okay, this is the ranking, right? And then
Mm,
based on the ranking, I just kind of sort the posts and store it somewhere. And that is the interesting part, right? So let's say for each user, I store a news feed, or let's say a version of the news feed, and then it's like a stream of posts, right? It's a never ending stream of posts that I just keep scrolling for hours, and it will show me something,
right.
because it also suggests new things and whatnot, even if I'm not following someone. But that's a different thing.
Right.
The other important part is this is a mutable stream, right? Because you said
Mhm,
you can change the ranking depending
mhm,
on, okay, now this post is becoming more engaging or
mhm.
trending topic, let's push it higher. Or
Right.
let's say someone deleted a post, so you have to also remove it from the feed. So
Right.
this is a mutable stream of posts that you have to keep stored. You have to store it in
Yeah.
the database.
Right.
So what kind of database do we typically use for such a use case? I mean, uh,
Mm,
yeah, like,
yeah.
there's a lot of changes happening.
Same
it's
time.
it's a
Yeah.
it's also high scale. So
Right.
yeah, what are
Yeah.
your thoughts on that?
Right. Yeah. That's a very good question, actually. So if you see, it's a very straightforward use case where
Hmm.
you are fetching the data in an order.
Yeah,
You're lucky to have just access your table in a sequence way. Whenever the random access, or when you have to do filtering, then it gets tricky.
exactly.
In this case, a simple NoSQL database that can scale easily, or it could be simple, Mongo kind of thing, MongoDB, or even Postgres you can use. And Postgres has documents with simple rows, because, okay, we don't have any, you know, um, any fancy thing around it. It's a, you can say, metadata of the metadata post.
Hmm.
It's not the original post. It has just a
Yeah,
link to the original post. If the original post goes away, for example, it gets deleted, when I'm trying to fetch a news feed which has that deleted post, maybe I don't delete it right away. But
yeah,
when I'm giving it to the user, at that point, I not only delete it from that I'm going to return to the user, I actually go in the database and delete it. For example,
yeah.
it's a delayed deleting kind of concept.
Hmm.
So yeah, so it's a sequential access. It's the best and easiest way you can use any NoSQL database, I guess, very easily. It's a straightforward choice.
Yeah, yeah. That makes sense. So it's also the query pattern is simple lookup. So you just get my feed, and you just pass in the user ID and, let's say, a timestamp or whatever. Uh, and then it gives you like a whole list of, like, a feed in a lazy loading manner, because you don't want to just give them like 1 million feed posts or something. You just give them like 10 at a time, depending on the device you're using. Maybe on a iPad it might be like 20 at a time. I'm just guessing a number. uh,
Right.
and then it needs to be, you know paginated. But the
Yeah.
problem with pagination, I have always seen is, when things change, when things go out of
Mhm.
order, the pagination also changes, because you're changing a lot of indexes, right? So how does that kind of
Mhm.
look like in, typically? Because so if I'm an interviewer, I would really be curious to see how the candidate, talks about this stuff, because this is really interesting for me.
Yeah. So I don't know. I don't know the answer of this thing because we are dynamically changing it, and the pagination is simple. It's a number. Okay, that's the last thing I have fetched, and please give me the next 10 things.
Yeah.
Uh, but uh, but that thing has changed. It's already. For example, the last thing that I read, it was already moved up
Up.
or
Yeah.
down. Or went away completely. I guess, I mean, the system has to develop a mechanism to figure out that, okay, what happened to this thing. Oh, so for example, the client can actually tell, oh, I have seen the 20 posts and this is the last post I've seen.
Mm.
Then it comes to the system, then it figure out, okay, so the newsfeed generation system also tells me that 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 the new items have arrived. Which means the previous pagination does not work anymore, at
Yeah.
least.
Mm.
There is already some intelligence in the system. Oh, this guy was on the third page, but now the third page is fourth page because the 20 new items have arrived.
Yeah.
So there is some difficult algorithm going on that really know that, okay, the data I have passed, this is what. Or for example, they can actually give the whole IDs of all the. For example, if you scroll 100 items, they can simply pass the 100 items back
Mm.
to the server, and server then figure out, okay, these were the items, and then I can. uh, I mean, what I've seen personally, that if you scroll down too many pages, then it can refresh the whole page and it
Yeah.
messes up everything. Or I
Yeah.
see the same post in a different order.
Exactly.
So at a certain time you can really do that. You can show a proper order, but then if it's too long, they refresh the whole page, I
Yeah.
guess.
Yeah. Yeah.
Yeah.
Yeah, what I've seen, I mean, not in Instagram use case because I never worked on Instagram, but uh, in some cases, so there are two types of problems, right? Like one is a simple pagination where your data is not changing. It's, let's say, a
Hmm.
historical. So let's say you're looking at your transaction history or order history, that doesn't change. So you can simply paginate, even if you have thousands of order, you can do that because it's not changing. Then there is a dynamic version, but where you also need pagination, so
Right.
that keeps changing. So what I've seen is they keep like multiple versions of the feed or the feed, and then so even the machine learning model, or even if new posts are coming up, right, it takes some time for them to say that, okay, this post now has higher ranking or this should go below that. So let's say
Right.
there is like, I don't know, few
Mhm.
seconds here and there. So you keep like a new version, and then as soon as there is a new version of the feed, you
Right.
just filter out the already seen
Already seen.
posts from the
Mhm.
user, and then you just give them that. Of
Yeah.
course, I have not seen it working at a very high scale,
Right.
but that
Yeah.
was the idea I came up with.
Yeah.
And
It- yeah, it's probably you have a different you can create a new generation of feed. So the
yeah,
previous generation is old generation, the new generation says, okay, there's
exactly.
a new ranking, something big change has happened,
Yeah,
so
yeah, yeah,
please refresh the whole page and you see it again. Yeah, that's
exactly.
and even link for LinkedIn, I have seen that if I see a post, for example, I liked it or commented, and now I refresh it again, that post is gone actually
Yeah,
because I've already seen it. So it
already
was
seen it.
highly ranked because and I interacted with it, but the system
Mm,
actually knows that, okay, I don't need to show this thing again.
yeah.
So it's again a filtering part that I have fetched again. If I'm gonna return 10 items, so I'll fetch 20 items and then filter some out because of certain things. This guy has already interacted enough, or it has, because the news feed is also, they're measuring everything. They're
Mm,
measuring how much time you're spending reading it, or interaction is okay as actual behavior, but they know everything. They measure every data. From that they can actually filter your stuff.
mm,
So I mean, yeah, if you again going back to the Twitter model, so the filtering parts, the multiple filtering layers that eventually filter out certain stuff and then they return.
yeah,
That's why it gets so messy, the feed.
yeah,
Because I don't like feed that way, because I say I lose lose this. Okay, it could. I mean, the idea is it is random, and sometimes they'll show their stuff based on whatever the algorithm
Yeah,
I
yeah,
have. And I don't care if I miss something important, because that's what the behavior of the server is. So I've
absolutely.
learned that behavior. So newsfeed is always messy. That's why, for example, Facebook actually tried it, but they removed it. But Twitter has it, the tabs, So
Hmm.
now I have multiple tabs, because because the feed has gone crazy. Yeah, I'll lose the important stuff. So I'll have different tabs, and then those tabs have certain users, and I want to see all the posts. So
Yeah,
then this means I have to have the same feed is there, but now the filtering, or now that the chronological sequential access is all gone too.
all gone.
Now you have to, okay, this tab has 5 users, go fetch the last 20 posts of these 5 users. Now the database design is all messed up.
Yeah,
You made your design based on sequential access. It's no more sequential, so a big design change is coming. So I mean, these are the factors practically. When Facebook either did it or not do it, it could be a bad user experience too, but sometimes it's a technical challenge too. There
yeah,
could be a bigger change they really need. Yeah.
absolutely. And you're right. I've seen like 100 problems with the feed generations, and it just shows me some random posts. Let's say LinkedIn's feed generation. I don't know how it works, but it sometimes it just shows randomly 2 weeks old, 1 week old post, and there is no
Mhm.
latest one. So I don't know what goes behind that. It definitely is a complicated system, as we can imagine. So yeah,
Mhm.
feed generation is a huge thing, and we can only guess how different patterns could be applied here. But of course,
Mhm.
different platforms might have different workarounds, different hacks here and there to make things work, because they have different business context attached to it, right? Like Instagram works differently, LinkedIn works differently, depending on the models they have. uh, Cool. I want to talk a little bit more on the fetching side. So you mentioned there is like a pull and push model, and then you also need to use like a hybrid model on the client side. So how does that typically work? Let's say, so there's I always seen this celebrity problem where there's like millions and billions of followers for a certain celebrity. As soon as they post, you need to do these many push notifications, but you of course cannot, because there is always some technical limitations. So how do you classify that okay, this is what gets priority, and then everything happens in a delayed manner?
Mm, yeah. For example, the notification part is over here. When a
Hmm.
post is done, we push it into queue, and then the notification service uh, does the work. But let's say if a celebrity has like notification means I need to notify. So there are two parts, right? One is uh, I think you have notification action too. That okay, I
Hmm.
follow this guy, but please notify me everything that you do.
Yeah.
So if you have really subscribed to them and notify, get the ask the system to notify me. So in that case, you have to notify all of them. But again, it's a step by step process. You push that thing to managers. So the one action is when you put it in the queue, the notification service it does all the heavy lifting. It actually
Yeah.
figures out what is the algorithm. It's a billion plus users, let's say, and how do I do it? But it has to, because that's your agreement with the users that I'll notify you. YouTube does it, I guess. So many people have like millions of followers, and they need to notify. Uh, One is that part. Again, this whole notification, the push notification we are saying, uh, it involves a complete design. It's your side, and then all the notification mechanisms on the mobile and tablets and
Yeah.
everywhere. Apple has their own server, and then they push it. So that whole thing needs to be carved out if you really want to. I think it could be a full-fledged system design problem, how
Absolutely.
how the message goes over there. Um, when I'm online, and uh, I do see a pop up, right? Sometime, I don't know,
Hmm.
in YouTube or LinkedIn. I never saw it. probably somewhere like on the phone, I don't know. But if I'm online and I see a pop-up, I can actually click on it to see that, oh, which is the post. uh, in Facebook, I think they do it on your on the pages that you own or something.
Yeah.
They do that. But again, it's the scale issue, and eventually if it's a very crucial use case, then you have to scale your services and the servers around it that way, that okay, you can actually, it's always a gradual process.
Yeah.
You estimate first and put the resources based on that estimation, and then grow or shrink your resources based on the usage. Um, it's it's a typical, models. Even the partitioning part, the we never discussed the partitioning over here in a database, but in the services, the partitioning works too, right?
Yeah.
That you partition the users on different instances of the microservices, and then they're responsible for doing that too. Um, yeah. So what was? Did I answer your question? I don't know. What was your other question?
No, I think you kind of did. Like, you know, there are like several parameters to for the notification service to actually notify the users who to give priority, who to not give priority. Also, from the client side, if they're not online, let's say I'm not open my app, I'm not there. So it is okay to give me the notification in a delayed manner, or whenever I come online, the client can pull, okay, give me all the notifications and things like that. So I guess, I mean, the main question was, when to use the pull versus push model.
Okay.
But I think, based on what I understood, it depends on the type of post, who is
Mm,
posting it, if the person is online or not. Sometimes I don't know if it works that way, but there can be some geographical considerations as well. Like, if I
yeah.
am posting, I'm in Berlin. If I post here, all my Berlin friends should see it first. I mean, it depends on what priority you give. And then you also mentioned about, so in YouTube there is a subscribe button, but there is also a bell icon where you can get notified. And this reminds me, please subscribe to the channel if you haven't yet, and also press the bell icon so you get notified using this notification service. Uh, yeah, so there are like different types of parameters. There's liveness check, if user is live. There is
Mm,
bell icon thing if they have opted for getting notified. There is
mm,
geographical thing. There is definitely the engagement stuff, like how close this follower is to someone else.
yeah.
So I think those are all inputs given to the notification service, and then it's
Right.
again a queue. So it processes asynchronously and then decides how this user should be notified. It can be a web notification, I don't know, an email, or just a pop up, a push notification.
There is
So
some machine learning around it too, right?
yeah.
Facebook tells you, oh, this guy has posted, this person has posted after a while, that kind of notice. So there's some intelligence going on, that,
Ah.
oh, I follow this person, and they, so one is a notification message that appears in all my notification count, you can say.
Mm.
Just like in LinkedIn, you can see, oh, I get all the notifications that, oh, someone has liked it, or or interacted with my post in a way. The other is the push notification, which the people who want to be notified. So this notification service has two parts. One is actually storing the notifications in a system, and then so that when you fetch it, you see all the notifications somewhere in your web page or your app. And the other is push notification, that okay, you have actually asked for it, so these guys have uploaded a new thing,
Hmm.
and then you can actually click on the notification. So yeah, um, yeah, I guess it's a little straightforward, but we need again some intelligence and storage, and then it's again a reverse chronological order to so fetching those notification is straightforward, I guess,
Yeah.
till now until it becomes complex.
That makes sense. And I want to highlight one more pattern that we
Mm,
discussed very briefly. That whenever you send this notification, or I don't know, somewhere else, yeah, the feed generation, uh, we don't send the actual data with it, right? We just send the metadata. And that's really important because in the feed generation, you remember if someone deleted the post, you don't have to worry about deleting the item itself from the feed. That can be filtered on the client level. Similarly to notification, what happens if you've already told the notification service that please
Mm,
notify, and then the
mm,
post was deleted? So, I mean, it depends on what stage you are. If it's already sent, you cannot pull it back,
mm,
but you can do some filtering there. But if you have
mm.
already sent the data, you have to actually delete the data, because then you can no
Yeah,
more control that. And in real world, I think when you're running like a huge campaign, so I
right.
work for a CRM company called HubSpot. People run huge campaigns and then they say, oh, please stop the campaign because it's I missed something, and then you have to stop millions of
Yeah.
messages that you're already publishing. So
Mm.
real world is slightly different because you need to
Yeah.
have all these
Yeah.
checks and
Mm.
abuse protection and whatnot.
Yeah.
But yeah, that is a good pattern to follow. So always send metadata across and not the actual data, and
Okay.
always try to pull it. So would you agree, or there are some exceptions there?
No, that's the best way. It's the smallest data. You pass it to this client or the user, and then when they click it, at that point you fetch the data. If the
Fetch the
data
data.
is deleted or removed, at that time you can show the message. Or the
Yeah,
post is deleted, or there's something went wrong. I mean, with Twitter, it happens a lot of time, right? People do post and then they have to delete, and
delete
then
it. They can't
everyone
edit it.
knows. Yeah, they can't edit it.
Yeah,
So yeah, so that's always a good behavior.
yeah. I want to talk one last thing, and we'll kind of try to summarize whatever we have discussed so far. Of
Okay.
course, it's kind of impossible to discuss everything in depth, but I think we have covered some of the nice patterns that we should typically follow.
Mm,
Uh, and then we'll talk about like the kind of to dos or things to follow if you want to excel in system design interviews or whatnot. uh, so I want to talk about a little bit more on the database choice. So that is a big area typically whenever you talk about NoSQL versus SQL. Of course, NoSQL is a entire bucket of 100 types of different databases.
right.
uh, and then comes replication, partitioning around that. But what is your thought process when you go about selecting a NoSQL versus a SQL, and like what is the reasoning behind it?
Yeah. So yeah, if you summarize, it's a big discussion,
Yeah,
but let's say at a high level, if you want to discuss NoSQL versus SQL, and NoSQL has so many different types, and there are specialized cases. Or this is a
yeah,
document store, this is a columnar store, or this is a graph database, or this is something, right?
yeah.
But generally, the shining feature both these systems they promote. One is the ACID, the other is the base.
Mm,
ACID means you're atomic, and you have all those high consistency models that you really want to guarantee stuff. And they say, okay, we are very consistent, but we'll take a hit on availability in cap theorem terms, right? Partition tolerance is there, but consistency is there, and availability will lose. Base is basically available, so they say, oh, we'll go with high availability and eventually consistent. Most of
mm,
the time, for example, news feed, okay, you don't see the feed item for 5 minutes, it's fine, but eventually you'll see it.
yeah.
So ACID versus base is a clear, division. The other is the other is, you can say, the specialization among the NoSQL databases, which I was referring in the beginning. That, for example, the document source MongoDB. MongoDB has evolved a lot. I would recommend reading their paper. There are a couple of good papers. The one recent paper and the old paper. Their paper, and even I have not read about the Postgres uh, paper yet, or if there is any new paper, but they have done some remarkable job. I think these two, 3 papers combined will teach you a lot. Okay, what is
Mm,
happening and how they are storing the data, different kind of data, and introducing all these different indexes.
yeah.
You have secondary indexes in MongoDB, and over here you in Postgres you are storing a SQL, a document kind of Mongo kind of a JSON or Bison object you're storing over there. So overall, this division is straightforward over there. The other thing that people generally discuss practically is the scalability part.
Mm.
They
Excellent.
say the NoSQL databases are easily scalable
Mm.
because they manage a lot of partitioning and replication, which is true as well. In MySQL side, you have to do your own stuff.
Mm.
But like as the Facebook says, we have done it, and we are running one of the biggest. So it's difficult, but let's say legacy system is there. If you want to really do it, the scalability, you have to manage yourself.
Yeah.
Over here, especially when you are starting something new, it's very easy to go with the MongoDB, or even so that the scaling part is handled automatically. So
Yeah.
these two big discussions, I think, very important. Then, yeah, practically or in a system design interview, another discussion is very important, which is you need to see your query models.
Mm.
The way you're storing data and the way you're querying your data.
Yeah.
For example, NoSQL does not allow uh, complex queries. You cannot have free joins. You can have some kind of joins, or some way you can either need to introduce new tables, but complex queries are not possible.
Yeah.
So they are scalable, they are easily manageable because of that.
Yeah.
Because they say, oh, complex stuff, we are not doing it, or if you want to do it, it's more complex to do that over here.
Hmm.
Over here, you can easily write complex queries if you really want complex relationship between your objects. So definitely your query pattern is very important. As we discussed, the sequential access, okay, it's a straightforward, we can do this and that or whatever. So query pattern is very important. If you have to have many joins, um, the partitioning actually part is becomes bottleneck too. If you have partitioned your horizontal
Yeah.
versus vertical partitioning, if you have different columns going, same table, three columns in one table, one in one side, on the two tables, and two columns on the other side, and because your query is telling that, oh, certain queries, they only need to access three columns,
Yeah.
so the remaining two columns can be stored in other ways, so that this server has lesser space usage, and the query is efficient over there. So like I would conclude it in this way, that okay, these three things keep in mind when you're discussing this thing, and it's you should practice it, telling this thing in an interview.
Yeah.
An interview is the battle against time. You need to tell all these things, or at least mention them in the interview, and then if interviewer feels out, either, I mean, they want to dig deeper, really want to test your knowledge, then you have it. But
Yeah.
if you have not referred them altogether, then again it tells that, okay, maybe this guy does not know about these complex stuff.
Yeah.
But yeah.
And you can't know everything, right? I mean, it's better to accept that, okay, I know at a high level, but I don't know deep how it works because I never worked with it. It's totally okay to accept that. I mean, the interviewer is there to just get some data points out of your knowledge and your experience, and not to prove that, okay, you don't know this and you don't know that. So I think those are great points to keep in mind whenever we talk about SQL and NoSQL. And of course, NoSQL is developing every day, like new features. So I also recommend these white papers, as you mentioned. I would also recommend reading the DynamoDB white paper, the new one, the 2022.
Yeah.
And I haven't read the Cassandra related white paper, but Cassandra is now going to support ACID transactions as well, with the with some new algorithm called Accord. I haven't read it, but I'm going to read it because I have to do a podcast on that. But it is going to be interesting. So, and then the other part of the world, it's the distributed SQL, which is
Yeah.
becoming more and more popular. So I mean, maybe it's not that relevant from a system design interview point of view, but it's best to know that as well. So I would also recommend reading the Cockroach DB white paper and the Yugabyte DB documents. They have like amazing, uh, you know, reasonings behind why distributed SQL and why not.
Yeah.
Um, I also did a podcast, so you can also check that. But yeah,
Nice, 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 nice. So yeah, so SQL versus NoSQL, and then versus new SQL as well. All the Cockroach DB and the
yeah,
famous DB. The design is evolving, and and they are actually it's a hybrid model. They're taking the
Mm,
best of the both the words and trying to put over here, but it's mostly linked with the cloud access and all that. I have not personally used it, but read about it. So I mean, if you are really interested, everyone like watch your thing or read about it. Um, the so that model, the columnar store. So key value store, the classical, the Amazon Dynamo paper, the original
mm,
paper, 2008, I guess, that was a masterpiece. It is as relevant as possible. You can
yeah.
read it today. I have complete chapter on it in my course, Grokking the
Mm,
Advanced System Design. And then the columnar store, like the Cassandra, or that is a different thing. I mean, if you have not read on infinite columns kind of thing, you should read about it, because this gives you another dimension.
absolutely.
um, the big table, the classical big table, it works great. And then once you know the big table, then you can actually read about all these papers easily, because it's the same model, and they're tweaking it and understanding it. So yeah, I guess there's a lot of thing happening around the storage.
Yeah.
We haven't discussed compute part any right over here, like
Yeah.
uh, the Spark and the MapReduce kind of. It starts with MapReduce and goes all the way very complex.
Yeah.
So compute part, storage part, these are the two basic parts that I mean you I mean you can guess, I guess you can specialize in one of them if you really want,
Yeah.
and that will be your thing. Yeah.
Absolutely. I mean, of course, as you mentioned, this looks like a okay, simpler, high-level overview, but each of these components are really, really complicated if we talk about them in the real-world context. And we cannot, I mean, in the interest of time, we cannot discuss everything. But I guess we have covered a lot of ground to get people started understanding the template, understanding some of the patterns that we have discussed today. I hope it will help a lot of people to understand at a high level using the example of Instagram, what we discussed today. Uh, if you like this video, please press the like button, subscribe to the channel, hit the bell icon so you can use our notification service there, and also check out the courses from Arslan. They are pretty interesting if you're focused on system design, if you want to learn at a high level and also in deep. And we've also shared some of the white papers that everyone should try to read in their lifetime, because it's such an amazing space. It's growing every day. Um, yeah, so I think we have covered a lot of ground. So we might be able to do more episodes depending on the feedback that we get from viewers, because there's so much to talk about. And I really enjoyed the discussion. I hope you did too, Arsalan, and thanks a lot for joining, and looking forward to collaborate with you more.
Yeah, thanks a lot. It was fun, and this is one of the interesting subjects, right? I mean, you can talk a lot. Distributed systems are really something that I like to talk about, read about, and learn from other people. And the best way is start teaching. If you
Yeah.
start teaching, you will learn too. So yeah.
Absolutely. Cool, thank you.